Caffeine is often seen as just a quick fix for morning brain fog, but underneath the buzz lies a potent molecular tool that interacts with the most essential components of cellular health, especially the mitochondria, our cellular power plants. The way caffeine supports mitochondrial function is far from accidental. It activates ancient biochemical pathways tied to energy regulation, stress response, and gene expression, making it far more than just a mental stimulant. At the mitochondrial level, caffeine exerts some of its most profound effects by stimulating AMPK, the cellular energy sensor that gets activated when energy is low. When AMPK is turned on, the cell shifts into a high-efficiency mode. It burns fat, improves glucose uptake, and, crucially, encourages mitochondrial biogenesis, the creation of new, more functional mitochondria. These new mitochondria are not only more efficient at producing ADP, but are also less prone to leaking reactive oxygen species, ROS, the damaging byproducts of energy production. This essentially helps the cell do more with less, while staying clean and stable under pressure. Caffeine also enhances mitochondrial efficiency directly. In studies on muscle and liver cells, caffeine appears to improve the coupling of oxidative phosphorylation, meaning more energy is generated per unit of fuel without as much waste. That means less heat, less oxidative stress, and more usable energy for essential cellular functions like repair, detoxification, and protein synthesis. It's like tuning up an engine so it runs smoother and cleaner at lower RPMs. Beyond performance, caffeine helps mitochondria deal with oxidative stress, which is both a cause and consequence of mitochondrial aging. ROS are inevitable byproducts of respiration, and in small amounts they're manageable, even useful. But over time, excess ROS damage DNA, proteins, and lipid membranes, especially in mitochondria themselves. Caffeine, either directly or through polyphenol like chlorogenic acid, has been shown to reduce the buildup of ROS, improve antioxidant capacity, and upregulate genes related to detoxification and repair, such as those in the NRF2 pathway. This means caffeine doesn't just prevent oxidative stress, it helps the cell bounce back when stress does occur. Another underappreciated angle is caffeine's influence on gene expression, particularly through its effect on signaling pathways like CAMP/PKA and calcium flux. These cascades can reach the nucleus and affect the transcription of genes related to metabolism, inflammation, and longevity. For example, caffeine appears to upregulate PGC-1A, a master regulator of mitochondrial biogenesis and oxidative metabolism. It may also influence FOXO transcription factors, which govern cell survival, stress resistance, and longevity-linked genes. In essence, caffeine acts like a switchboard operator, subtly dialing up the expression of genes that help cells thrive under stress. These changes aren't limited to one tissue. In the brain, caffeine protects neurons by improving mitochondrial resilience and limiting neuroinflammation, potentially reducing the risk of neurodegenerative diseases like Alzheimer's and Parkinson's. In the liver, it supports fat oxidation and detoxification. In the heart and skeletal muscle, it improves endurance by preserving mitochondrial integrity and enhancing energy flow. These organ-specific benefits stem from the same core logic. Caffeine keeps your cells well-fueled, adaptive, and less prone to breakdown. What's striking is that these mitochondrial benefits don't require megadoses. Even moderate caffeine intake, equivalent to 1 to 3 cups of coffee per day, can produce measurable shifts in mitochondrial gene expression and stress signaling pathways, especially when combined with other beneficial stressors like fasting or exercise. So while caffeine is best known for keeping you awake, its deeper gift may be keeping your cells awake, energized, protected, and ready to face metabolic stress. It doesn't do the work for your mitochondria, but it helps them work smarter, cleaner, and longer. In a world where mitochondrial dysfunction is linked to nearly every age-related disease, that's no small feat.